So decision tree, as the name suggests, or some of you might have gone through the kind of details prior to this class. Basically, it is an inverted tree, right? Tree is basically leaves will be top, right? Any tree. Uh, I do not have much knowledge about biology, but anyhow, like kind of any tree, if leaves mostly like points toward the sun, right? Decision tree is the only tree where your leaves will be downward, right? You'll have something like this coming down, right? Let's say I'll go back to the previous slide. Let us try to understand what does decision tree mean. Whenever we want to, either we can use it for classification, we can also use it for regression, right? Whenever we have categorical variable, we want to categorize, put into groups. So that is where your classification tree will happen. I have a continuous data, I want to segment into different range. Then also your regression tree. So decision tree can be used both for classification or regression, right? But regression, it is only the like kind of putting into groups, right? Not in terms of predicting something. So what does a decision tree do? It simplifies our objective, right? Rather than looking into many parameters, rather than looking into 100 of predictors, can I take certain number of predictors, right? And create a simple, because this is the only thing which somebody looking into visually, right? And I think in the beginning of our discussion, I had explained that you might create a very complex model with neural networks, or very complex model with a, let's say, this predictive regression model. You can use lasso, lars, and all those things, high flying word, and say that, okay, I have used this regression and this is my result. But when you go and try to explain to your stakeholder, nobody understands those language, nobody understands statistics. It becomes very difficult. Decision tree is one of the tool, right? One of the area, right, which is very simple to like kind of explain to the stakeholders. If I just go by and this and say that I create something like this without any statistical explanation, I have created this, and go to a director of banks, or the like kind of executive directors of a bank, and say that this is how I have created a decision tree model. What it is going to say? It is going to predict a credit like kind of worthiness of a individual. If somebody is a homeowner, marital status married, he is a good credit worthy. Homeowner, marital status, single, divorced, annual income greater than $80,000. He is a bad kind of like his credit worthiness is poor, right? So this might look strange, right? Then obviously you have to explain why somebody who is having a annual income less than 80K having a good credit, your model is predicting good credit worthiness. Why somebody who is above 80K having a bad credit worthiness? That is a additional explainability you have to give it to your model. What it shows, if I just go with this rather than creating a logistics regression or a polynomial regression, that okay, I can calculate somebody's credit worthiness. Simply I can, within few slides, I can explain to the stakeholders, okay, these are the characteristics, or these are the parameters we should put in our production before providing a, or before offering a credit card to someone, right? So in comparison to other models, in comparison to other complex algorithms, decision trees mere advantage comes from the simplicity of the model in explaining, right? That doesn't mean that creating the model is very simple, right? If you actually go through the details of it, it has a lot of parameters similar to regression. Only thing is that how you visualize it, right? The aspects of visualization of showing a complex algorithm in this kind of tree structure, which is appealing to many of the like this kind of financial organizations, or healthcare, or any kind of industry, right? So if I just show you this, right, homeowner. So what? How many parameters I've considered for my model? How many different parameters? What I'm predicting, that is credit rating, good or bad. So that is a classification, right? Somebody who has a good credit rating, or somebody who has a bad credit rating. So that is a outcome response variable that I want to predict, right? What are my predictors?
So whether they are a homeowner or not, what is the marital status, whether married or not, and what is their annual income. Three
Okay.
parameters.
Three parameters or three variables I have. Which is the most important one?
Sir, I
Out.
think it will be annual income.
Okay. Why do you think so?
So because the credit rating, sir, I think that will be uh, very easy to predict whether their credit rating can be good or not. There might be a possibility that their income is very low, and they might have a problem of overspending. So there is a possibility that their credit rating will not be very good. So that
Okay.
I think will be important.
Okay. So for a decision tree, this you have to remember whenever, and I'll show you actually when we do this in enterprise manner, why we were discussing this. Whenever a decision tree is created, it always try to, like in your regression, right? Regression model, whenever I'm creating, I first in a stepwise regression, I try to find out which is the predictor which is giving me the most predictability. Then I'll take the next, right? Basically incremental wise the other predictors will add value, but first predictor which I'll choose ideally should be the providing much more explainability to the model. So in a decision tree it is a stepwise, think it as a stepwise regression. The first parameter which is being shown, which is whether somebody root node, right, which is somebody whether having a home or not, right? So that is the most important variable, followed by the next one, followed by the next one. If I want to put a hierarchy in this structure, right? And why, like you'll say, why homeowner? How do I know? Obviously, here that information is not given. When you create in the SaaS enterprise manner, I'll show you how this model is selecting, right? Which is my most important variable, which I should consider for my decision tree. Then the next important one, then the next important one. So in that logic, right, I have not explained why and how that choosing, that anyhow I'll show you. Today I'll discuss some of the parameters. So home, having a home or not, so that is the most important variable, followed by the marital status, followed by the annual income, right? Decision tree or classification, we can use both for classification regression. It can be a binary classification, yes, no, somebody credit worthy or not, or finding multi-class classification, right? Putting into different average credit worthiness, good credit worthiness, or poor credit worthiness, right? That also we can create using decision tree. Then regression, how much salary range depending upon different parameters, right? Education level, internship, and all those things. What salary bracket will get into, right? Not so there when it's a continuous group, it is not able to like create a perfect number. Okay, he will get 8.12 salary package, which generally we use for a linear regression. Here it will put into a bracket. Okay, if somebody having this kind of background, this kind of internship, this kind of uh, other information available for a student, which salary bracket that person will feel into, or that person will be like get a job or a, get an internship, right? So some kind of parameters which you have to remember. Any node which is at the end, right? So that is like a leaf of a tree, right? Leaf node. Any node which is within the, which creates those leaf node, that is known as internal node. The line connecting a internal node to a leaf node is known as branch, right? Think that as a inverted tree. Generally in a tree, root will be in the bottom, in the below part, below ground, and tree grows up, then leaves comes, right? In our case, when you talk about a decision tree, think it as a inverted tree. This first node is known as root node, start of the tree, then internal nodes, then leaf nodes. Leaf nodes are nothing but leaves of a tree. Then the branches connecting internal node to leaf node as lines connecting internal node to the leaf nodes known as branches. Okay. So this is what I was talking about when, let's say I want to annual income I want to predict, right? I'm not going to exactly predict whether somebody will get $51,000 or $60,000, but I can predict which group of annual income they will belong to, right? or I can just predict in a binary way whether their annual income will fall below $80,000 or above $80,000, right? Depending upon all these kind of predictors or independent variables, right? Then the question is, how do you make sure? Like I said in the previous case, when I showed you that example, homeowner was the whether somebody is having home or not, followed by the marital status, followed by the annual income, right? Those are the structure of your decision, right? First, you'll consider whether somebody having home or not. That is the most important parameter, followed by the your marital status, followed by the annual income, right? How do you decide on that? Which is the most important variable, right? If it is a categorical variable, we use this kind of chi-square, Logworth, entropy, and Gini. If it is an interval criteria, right? Continuous data. Interval means continuous data, right? We used variance. Variance means the average distance, average difference from the mean, right? Or probability F Logworth, right? So again, like I have not shown you in the SAS enterprise manner, I'll show you in the next class. But right now, I'll just show you how the calculation happens manually. If you want to calculate how this calculation of Gini index and entropy happens, right? I'll come back to this. Let me just show you simply Gini index for today's class. Then I'll discuss entropy and other things in the next class. So Gini index is basically like what it says, similar, the structure or the kind of philosophy of Gini index and entropy is almost similar, right? Entropy is the amount of disorder in a set, right? If I just imagine like in the physics class, if I put a glass, it breaks down, right? Entropy is increasing, right? Disorder is increasing, right? Decreasing disorder is a, you need certain energy, certain task, certain effort, right? Gini index is similarly. So what it says, if I have a like kind of 1,000 data points or 10,000 data points, right? They are not classified properly, right? By using decision tree, am I able to create that groups which will decrease the disorder, right? Which is known as disorder in your entropy, that is known as impurity, right? In your Gini index. But the philosophy remains, whether you call it as a disorder, chaos, impurity. Because what happens if, let's say, your home, which is a mess, like everything is lying here and there. If I go and if you someday if you go and clean it out, everything in a proper place. So what you are doing? You are decreasing the disorder. You are decreasing the impurity, right? So same thing, same situation or same philosophy here in Gini index or in your entropy, right? Think about a scenario. I have 12 customers, right? Out of 12 customers, 6 are, so this 6 and 6, 1 means C1 means, let's say they are buying my product, C0 means they are not buying my product. So I have 12 customers. Out of that, 6 customers are buying my product, 6 customers are not buying my product, right? So what will be my Gini index? 1 minus whatever the classification ratio, 6 each people are, who are not buying, divided by 12, that is my total customers, minus 6 by 12. Again, in this both the cases, I have 6, right? So my Gini index of the parent node, original data set, not parent node, original data set is 0.5, right? So now what happens? Let's say I have two different variables, right? One variable which is, let's say, if I know their home ownership, right? Let's say B is the home ownership and A is the marital status, whether somebody is married or not, right? B is the home ownership, A is the marital status. If I use this criteria, let's say A is the marital status, somebody who is married, somebody who is not married, right? In this group, 7 people, total 7 people will come, 4 plus 3. In the other group, 5 people will go, right? But in this 7, how much, what happens? 3 are my customers, 4 are my non-customers. In the other group, 3 are my customers and 2 are my non-customers, right? So now what will happen? Again, I'll calculate my Gini index. 1 minus 4 by 7 square minus 3 by 7 square, right? I hope you are able to remember the formula. Classification, whatever the ratio, square of that. So in this particular case, for this node, what will be my Gini index? 1 minus 4 by 4, C0 is 4. Number of people who are not creating account with me, 4 divided by total number of customers, for this node, 4 by 7 square minus 3 by 7 square, right? So that will give me a Gini index of 0.4898. Similarly, I'll calculate for the other node also. 1 minus 2 by 5 square minus 3 by 5 square, right? That will give me 0.480. If I take home ownership, whether somebody having home or not, as my one of my variable, those people who are having home, 5 people, those people who are not having home, 7 people. Out of 5 people, those people who are having home, they are going to take my loan or take my this savings account offer. So C1 is 4, C0 is 1. Now what will happen? 1 minus 4 by 5 square. 1 minus 4 by 5 square is how much? 4 by 5 is 0.8, right? 0.8 square is 0.64, 0.064. Minus 1 by 5 square. 1 by 5 is 0.2. 0.2 square is 0.04. 0.04 plus 0.064. If I like 1, I subtract from my 1, that will give rise to 0.30. I hope I calculated properly. 4 by divided by 5 square. 4 square is 4 by 5 is how much? 0.8, right? 0.8 square is 0.64. Then 1 by 5, that is 0.2. 0.2 square is 0.04. 0.64 plus 0.04 is 0.64, right? I subtract from my 1 minus 0.644 or let's say 0.65, right? Ideally it should come how much? 0.35. I have to see into calculate what is 1.320, right? But the step remains same. Similarly, here if I calculate 1 minus 5 by 7 square minus 2 by 7 square, 5 divided by 5 plus 2, that square, 2 divided by 7 square, right? So that will give rise to Gini index of 0.4082, right? So now what happens? Which variable I should take? If I take this variable which is married or not, I'm creating two nodes. Each node has a Gini index of 0.4898, 0.480. If I'm taking home ownership as my another variable, I am having two nodes which have Gini index of 0.320 and 0.4082, right? So simple thing, you take a weighted average of number of data points you have, right? You have total 12 data points. In the first case, when I use the A node, A variable, that is the marital status, it divided into two nodes having 7 data points here. In the N2, there are 5 data points. 7 by 12 multiplied by the Gini index of 0.4898 plus 5 by 12 Gini index of 0.480. That will give the average Gini index for this variable is 0.486. If I take marital status as my one of my key variable for classification, using that my total Gini index becomes 0.486. So gain is how much? From my parent original data set, the impurity index was 0.5. Now by using this variable, by using this marital status as a variable, my Gini index became 0.486. So there is an improvement of 0.014, right? But if I'm taking home ownership as my variable, right? Gini index, so these values are coming from this, whatever we have already calculated, 0.320, 0.4082, right? And when I calculate that, when I calculate the weighted average, so total number of data points 5, 5 by 12, 0.320, this is 7, 7 by 12, 0.4082, right? So the value is coming as 0.3715. How much improvement in purity or decrease in impurity is happening? Gain is basically 0.52 minus 0.55. 0.5 is in the original data set. Now the Gini index, by using this variable B, I'm getting a Gini index of 0.3715. So total improvement is 0.1285, right? So whichever variable is giving you much more purity, right? So dividing or classifying so that you have less disorder, less impurity, right? That variable you should choose, right? So out of A and B, I'll choose B. So that will be my first variable. Then I'll look into other variables. Out of remaining variables, which is my next variable, I should take into my model, right? So in this particular case, if I starting my model, I have only two variables. I'll take consider B first. Then if required, if I need more classification, I will consider A. If I have only two predictors or two variables, right? So this is one of the way to choose which variable you should consider for my model. Like in your regression, depending upon your R square, if it is improving your R square, you take those variables, right? If it is obviously p value is less than 0.5%, it has a significant value, and it is improving your adjusted R square or R square, right? Same thing here. The variable which is improving your purity or decreasing your impurity or decreasing the disorder, that you should take as your predictor, right? So you'll have a small calculation which I'll give by next class. You have to complete that. Again, that is a group assignment. It will take maximum 5 to 10 minutes. I'll share this slide. So go through the steps. So refer this slide, right? You just have to complete that calculation so that you know that you can calculate Gini index by hand, right? So I think I'll stop
Sir,
here
it's
for today.
520.
Yeah.
Sir, it's
I'll-
520.
Yeah. So I'll stop here today. So quiz will come around 5:25 in your Google Classroom. If some of your friends are still not online, ask them to be ready. 5:25 to 5:35, please complete your quiz, submit your quiz by maximum by 5:36, right? After that, I'll be closing the quiz, right? 10 questions, 10 minutes. I don't think there is any calculation. You just have to go through the options. Some options might not be there, right? So you have to answer within the options available, right? Chalo, all the best.